Welcome to the Explainer. Imagine, just for a second, that you're trying to find a very specific book in a massive library. But instead of using a catalog, your only strategy is to search every single shelf randomly until you find something that kind of looks similar to what you want. Sounds totally exhausting, right? Well, believe it or not, that is exactly how most AI retrieval works today. It's a process called dense vector search, and it has a pretty massive flaw. It can really only find things that look, on the surface, like your question. But what if AI didn't just blindly search? What if it could actually remember and navigate ideas exactly like the human brain does? Today, we are exploring a really fascinating system called HippoRAG, named after the human hippocampus. It's an absolute game changer that allows AI to store and retrieve information through a vibrant web of associations. So, traditional dense vector search basically fails completely when no single passage matches your full query perfectly. If the answer requires connecting two totally different thoughts from two different books, well, traditional AI just hits a brick wall. HippoRAG solves this beautifully. It doesn't just look for matching text, it navigates a web of connected ideas. It literally follows trails of logic, just like your own human memory does when you're, trying to recall a forgotten name by thinking about where you last saw the person. Okay, so here is our roadmap for today. We have a simple three-step journey to follow. First, the indexing path. Second, the retrieval path. And third, personalized PageRank. Let's dive right into step one, the indexing path, or building the graph. When you feed documents into HippoRAG, it doesn't just mathematically flatten them into numbers like normal AI does. It builds a living, breathing knowledge graph. Think about it like a giant map where ideas are the destinations and relationships are the roads connecting them. To see exactly how this map is built, we're going to use this single sentence as our anchor for the entire explainer. Professor Thomas at Stanford University researches the neuroscience of Alzheimer's disease. This one sentence is about to become the raw material for building human-like AI memory. This system basically runs through a quick 5-step process. First, it acts like a highlighter, doing named entity recognition to pull out the proper nouns, or landmarks, really, like Professor Thomas, Stanford, and Alzheimer's. Then it uses open information extraction to figure out exactly how those landmarks interact with each other. It maps it all out into a graph, connects any synonyms, and finally, it logs exactly where it found this information in what's called a passage matrix. And this brilliantly illustrates exactly what happens during that extraction phase. The AI turns raw text into structured data: subject, predicate, and object. So the AI doesn't just vaguely know that Thomas, Stanford, and Alzheimer's happen to be in the same paragraph. No, it knows explicitly how they relate. Thomas is the subject, researches is the predicate, Alzheimer's disease is the object. These become the literal nodes and connecting lines in our AI's new brain. But you might be wondering, how does the system handle paraphrasing? Because in the real world, one document might say Alzheimer's disease, and another might just say Alzheimer's. To a basic computer, those are completely different strings of text. HippoRAG solves this by using a meaning calculator, a dense encoder, to evaluate all the nodes. If two concepts have over an 80% similarity in their meaning, it draws a synonymy edge between them. It's essentially a soft semantic bridge connecting variant phrasings so the AI understands they mean the exact same thing. All right, that brings us to section 2, the retrieval path, finding the answers. So now that our memory is built, complete with all those nodes, relationship edges, and synonymy bridges, imagine a user asks this exact question: which Stanford professor works on the neuroscience of Alzheimer's? Now, this query would completely break traditional AI. Why? Well, because you might have one document all about Stanford professors and a totally separate document about the neuroscience of Alzheimer's. If no single passage contains all those keywords together in one place, traditional dense search just gives you nothing. It misses it completely. But HippoRAG doesn't look for matching paragraphs at all. Instead, it extracts the core entities from your question, Stanford and Alzheimer's, then it measures their meaning and maps them to the closest matches it already has in its knowledge graph. So Stanford maps directly to Stanford University, and Alzheimer's maps to Alzheimer's disease. These two concepts are now our absolute entry points. They are the seeds that bridge the user's question directly to the AI's memory graph. And here is where the magic really happens. HippoRAG treats this query as a starting point for a graph walk. I want you to picture dropping two pebbles into a perfectly still pond. One pebble is Stanford, the other is Alzheimer's. When they hit the water, they send out ripples through the graph's connections. The search isn't just a one-shot blind guess anymore. It is a radiating wave of associative connections moving from node to node, seeing exactly where those ripples overlap. Which brings us to our final section, Section 3, Personalized PageRank, the engine. So how exactly do we calculate those overlapping ripples? To really understand this, let's look at standard PageRank first, which you might recognize as the algorithm that originally built Google Search. The idea is actually pretty simple. Imagine a random web surfer clicking links endlessly. Sometimes they follow a link, and sometimes they just randomly teleport to a completely different page anywhere on the internet. Over millions of steps, the pages this random surfer visits the most are deemed the most important. It's global, and it's completely unbiased. So the absolutely crucial point here is how personalized PageRank changes that dynamic. In HippoRAG, the surfer isn't randomly teleporting anywhere on the web. No, the surfer is intensely biased. Every single time they teleport, they jump right back to our specific query seeds, Stanford University and Alzheimer's disease. They start at Stanford, walk a few connection edges, and teleport back. Start at Alzheimer's, walk a few edges, teleport back. And this leads us to the ultimate aha moment of the whole system. Think about our graph for a second. Our biased surfer is walking outwards from Stanford University and outwards from Alzheimer's disease. Because of the relationships we extracted way back in step 1, Professor Thomas is reachable from both seeds at once. Probability is literally flowing into Thomas from two different directions simultaneously. Because he gets hit by overlapping ripples from both Stanford and Alzheimer's, his relevance score absolutely skyrockets. Now, to keep this surfer in check, HippoRAG uses what's called a damping factor. The damping factor controls how far the surfer is allowed to stray from those initial seed nodes. If it was, say, 0.9, the surfer would wander way too far, finding distant, irrelevant connections, probably ending up on a Wikipedia page about, 18th century spoons. If it was 0.2, they'd stay too close and completely miss those multi-hop insights. HippoRAG uses a damping factor of exactly 0.5. It is the absolute perfect middle ground between deep, multi-hop exploration and staying laser-focused on the original question. Actually, scratch that. There's one subtle hurdle here, node specificity. Imagine your question involved Alzheimer's and the United States. The node for United States is a massive hub, right? It connects to almost everything in the database. If you drop a pebble there, the ripples would flood the entire graph and pollute your walk with totally irrelevant data. HippoRAG counters this by giving rare concepts a much stronger initial gravitational pull than common hubs. The rare, highly specific concept dominates the walk, exactly as you would want it to. So, what is the final output of all this incredible math? The algorithm runs the PageRank walk 20 to 50 times until the probability scores stabilize. You now have a highlighted activated memory subgraph where nodes like Professor Thomas are glowing red hot with high scores. The final step? The system simply looks back at that passage matrix from step 1, finds the exact source documents that mention Thomas, ranks them by his high score, and delivers the perfect answer straight to the user. Okay, let's bring this all together. HippoRAG completely abandons blind vector similarity search. It stores knowledge as a structured relationship graph. It retrieves answers by taking associative graph walks, literally following the breadcrumbs of logic. And by doing this, it successfully mimics the exact architecture of human memory retrieval, finding what you need not by surface-level text matching, but by navigating the deep, underlying connections between ideas. It really makes you pause and think about the future, doesn't it? We spent years just trying to make AI search faster, but now we are actually teaching it to navigate and remember the exact way we do. If AI can now associate memories exactly like a human brain, seeing the invisible relationships between scattered thoughts across thousands of documents, what on earth will it learn to connect next? Thank you so much for joining me on this explainer. I really hope this helped clear up the incredible mechanics behind HippoRAG.